When we look at this function, we can identify that it's exponential because we have a base to an exponent, and then just this +1 and the -6 just is telling us how it translates. What is the domain of all exponential functions? All real numbers. Okay, and then we want to graph this. Again, hopefully you guys have something as a reference here. So this should be memorized. So what we have is we have 0, 1, 1 the base, -1 the reciprocal of the base, and then y equals 0. Okay, so we have all these things. What transformations are we doing here? What does the x plus 1 do? So we have left 1 and then down 6 because of the -6, and that's on the outside. Left 1, we can do this all in one step because this is going to change x, this is going to change y, so I'm going to do it all in one. So the left 1 changes the x, so we're going to subtract 1 from every x. And then the down 6 is going to subtract 6 from every y. So 1 minus 6 is -5. I'm just going to put e minus 6 here, and then 1 over e minus 6 here, and then y equals -6. Okay, so let's go ahead and calculate this e minus 6. So that's going to be 2.7 minus 6, and that's going to be about what? -3.3? Is that right? -3.3? My subtraction right there, you guys? Yay, nay? Okay. And then what is 1 over e again? 0.4. 0.4 minus 6 is about -5.6. Yeah? Everybody good? Okay. So now we can plot these. Y equals -6. 1, 2, 3, 4, 5, 6. And then -1, -5. 0, -3.3. And -2, -5.6. Okay, we do have an intercept, but at this point we don't really know what that is. Okay, so we have our points because they're listed here. I'm okay with that. Now, what is going to be the range for this function? What's the asymptote for this function? Let's start there. Y equals -6, and therefore it's from -6, and we're going up to infinity. All right. So now we have to find the inverse. First step for finding the inverse. What do you always have to do? What's the first step always in any function for finding inverses? First step. Yes, thank you. Flip the x and the y. So we come over here, and instead of y here, we have x equals e to the y plus 1 minus 6. How many terms do we have on the exponential side? 2. You cannot switch forms if you have multiple terms on the exponential side. You need to get the exponent, like the base, to the exponent by itself. So that means we're going to need to add 6 first. So this is going to be x plus 6 equals e to the y plus 1. And now we are able to change forms because there's no number in front of the base. If there was a number in front of the base, either a negative or a number, we'd also have to divide. But there isn't. We can change forms. What's the base here? What's the base in this problem? e, so log base e. Logs equal the exponents. What's the exponent? In this problem here, what's the exponent? Y plus 1, and what's the only thing left over? X plus 6. How do we solve for y? Subtract 1. By the way, that's really supposed to go here, but that's okay. So we subtract 1. So what we end up with is the natural log of x plus 6 and then minus 1. A couple things. If you put log base e here, you will get full credit. All right. I did change it to natural log because that's my tendency, but if you left it in this format, they're the same thing. That is not a preference. You can do either or. The other thing is you need to make sure to keep the parentheses. Some people will try to simplify this and say that this is x plus 5, but the problem with that is with the parentheses, this means that this moves left 6 and down 1, and that is not the same thing as the natural log of x plus 5. Like, you cannot combine these two. So the placement of the numbers does matter. You need to make sure you have that right. Okay? What is going to be the domain of this function? How does it relate to this function? The domain is going to be the range. So -6 to infinity. We could have solved by taking the input x plus 6 greater than 0, but we didn't have to because we already had the inverse function information. What is the range of every log function? All real numbers, but again, you could have just used the domain from here to get that. So now for this last part, which we didn't do in the last 3 graphs, is we're going to graph the inverse because the main focus of this chapter is logs. I definitely want to graph the inverse here. What's really nice about it is we actually have all the values we need right here. Okay, so if I have -1, -5 for my new function, I must have -5, -1, and then e minus 6, 0. And -2, oops, sorry, and then 1 over e, check that out, yeah, 1 over e minus 6, -2, and then instead of y equals -6, I now have, instead of y equals -6, we must have x equals -6. So we would have 1, 2, I should not have drawn this so far apart, 1, 2, 3, 4, 5, 6. And then we have -5, 1, e minus 6. That was -3.3, 1, 2, 3.30. And then 1 over e minus 6 was -5.6. So -5.6, -2. Wait a second. I drew this one wrong, you guys. -2, -5.6. That guy's wrong. This was -5, -1. I went -5, +1. Nobody called me out on it. All right. And this is, I don't know exactly where that's at. That's okay for right now. All right.